All right, everyone. So we're going to read pages 18 through 19 in the book. As always, I've already gone through and numbered my paragraphs for today's reading, so you'll want to do that as well. I will read through the page and then we'll go back and mark it together. So how is density determined? Remember the riddle about the sand and the feathers? Although they weigh the same, a kilogram of sand takes up much less space than a kilogram of feathers. The volumes differ because sand and feathers have different densities, an important property of matter. Calculating density. Density is a measure of the mass of a material in a given volume. Density can be expressed as the number of grams in 1 cubic centimeter, or G over cm cubed. For example, the density of room or water at room temperature is stated as 1 gram per cubic centimeter. Recall that volume can also be measured in milliliters, so the density of water can also be expressed as 1 gram per milliliter. You can determine the density of a sample of matter by dividing its mass by its volume. So down below you see the equation, density equals mass divided by volume. Sinking or floating. Suppose you have a block of wood and a block of iron of equal mass. When you drop both blocks into the tub of water, you see that wood floats and the iron sinks. You know the density of water is 1 gram per cubic centimeter. Objects with densities greater than that of water will sink. Objects with lesser densities will float. Watch a bottle of oil and vinegar salad dressing after it's been shaken. You will see the oil slowly form a separate layer above the vinegar. This happens because oil is less dense than vinegar. So we're going to go through and mark the text. So let's start in paragraph 1. I'm going to underline the volumes differ because sand and feathers have different densities, which is an important property of matter. Paragraph 2 has a lot happening, so I'm going to read through it while I mark it. I'm going to circle the word density because I know that's going to be an important word. Density is a measure of the mass of a material in a given volume. I already know that that's important, so I'm going to underline that. Density can be expressed as the number of grams in 1 cubic centimeter. That also sounds important. For example, the density of water at room temperature is stated as 1 gram per cubic centimeter. Recall that volume can also be measured in milliliters, so the density of water can also be expressed as 1 gram per milliliter. And I know that this one's going to be important because it's in bold. You can determine the density of a sample of matter by dividing its mass by its volume. And I'm going to circle that equation because I know that's super important. Let's take a look at paragraphs 3 and 4. I'm going to underline the end of paragraph 3. I didn't think anything was important in paragraph 4, so I'm going to leave that one for now. Let's take a look at the apply it. Apply concepts. Label the layers of colored liquid in the column according to their densities. So remember, the more dense an object is, the more it'll sink. So we're going to look for the heaviest thing, the one that has the most grams per milliliter. And that looks like honey. So that one's going to be the heaviest. And I'm going to cross that off my list for now. What's the next heaviest? You're right, corn syrup. Then what? Yep, the dish soap. And then, yep, then the water, because that's our 1. And our vegetable oil is less than 1, so that's going to be the one at the top. Now we're going to do a little bit of math. We need to calculate what the density of a liquid with a mass of 17.4 grams and a volume of 20 milliliters. Where would it be in the column? So I need to do the math first. So remember, density equals mass divided by volume. So I have my mass, which is, my mass is 17.4 grams, and I need to divide that by the volume, which I know is 20 milliliters. So that's going to give me a density of 0.87 grams per milliliter. The next thing I need to do is figure out where it would be in the cup. So what is it less than? You're right, it's less than everything. So it's going to be above the vegetable oil. So I'm going to try to write above vegetable oil. I did that very terribly. All right, now let's take a look at the challenge. So the challenge says, in which layers would a solid cube with 6 centimeter sides and a mass of 270 grams float? And explain. So the first thing we need to do is figure out the volume of the cube. So remember, a cube means that it has equal sides on all sides. So I need length times height times width. And because it's a cube, I know that it's 6 centimeters by 6 centimeters by 6. So I can take 6 times 6 times 6. And that's going to give me 216 centimeters cubed. Now I need to do a little bit of math. I need to divide my mass, which is 270 grams, divided by my volume, which is 216 centimeters cubed. That's going to get me the density of my cube. So when I type that into my calculator, I get 1.25 grams per centimeters cubed, or per milliliter. So now I need to figure out where that would fall in my cup. So I'm going to erase that so I can take a look. So 1.25. So let's take a look. My honey was 1.36. So it's less than honey. Let's take a look at corn syrup. My corn syrup was 1.33. That's still more, so that's going to be below my cube too. So let's take a look at my dish soap. My dish soap is 1.03. Perfect. So now I know that my cube is going to go between the corn syrup and the dish soap. So I'm going to write that down. Between corn syrup and soap. Perfect. If you need to pause for another second to write that down, you can. I'm going to move on to the next page. So page 19. I already have my paragraphs numbered. Suppose you were a gold miner in the 1800s, like the men in figure 4. One day, while panning through the sediment in a stream, you come across a shiny gold rock. How do you know if the rock is real gold? Since density is a physical property of a substance, it can be used to identify an unknown substance. You can measure the mass and volume of the rock and find its density. If it matches 19.3 grams per cubic centimeter, the density of gold, then you have struck it rich. I want to remember that the density is a physical property of a substance and can be used to identify an unknown substance. And then I'm going to underline the next sentence as well. You can measure the mass and volume of the rock and find its density. Let's take a look at figure 4. It says density can be used to identify substances. Estimate. Hypothesize which rock sample is gold. Then calculate the density of each sample. Circle the rock that is real gold. So let's take a look at which one I think it'll be. So it's either going to be A, B, or C. And B looks the shiniest, so I'm going to go with B. Now I need to go through and figure out the density. Now remember, density is mass over volume. So I'm going to have to do a little bit of math. So mass over volume. And I'm going to write down all the problems. Mass over volume. Mass divided by volume. And now I'm going to use my calculator to help me figure this out. So for the first one, my mass is 108 grams and my volume is 12 centimeters cubed. That means that my density is 9 grams per centimeters cubed. For my next problem, my mass is 126 grams. I'm going to divide that by the volume, which is 15 centimeters cubed. That gives me 8.4 grams per centimeter cubed. I have one more. The mass is 386 grams for number C, and the volume is 20 centimeters cubed. That gives me 19.3 grams per centimeter cube. Now in the reading, it told me that gold is 19.3 grams per centimeters cubed. So which rock is actually the gold? Right, C is actually the gold. So now I just have to figure out the bottom few questions, assessing my understanding. So identify. Maple syrup will float or sink in water because its density is greater than 1. Now remember, the heavier the object, it'll sink. And water's density is only 1 gram per cubic centimeter. So if maple syrup weighs more than that, it's going to sink. And finally, what is the mass of a sample of a substance with a volume of 120 milliliters and a density of 0.75 grams? Now remember, I have to take my mass, which is 120 milliliters, and divide it by a volume, and that's going to give me 0.75 grams per milliliter. So I just need to figure out what the V is. So to do that, remember I need to do a little bit of math, and that's going to give me 90 grams. Thanks for joining me, guys.